Okay, starting today, we're going to be looking at one variable statistics, which is what chapter 3 in your book happens to be about. And we've already talked a little bit about the idea of descriptive statistics and the fact that what you're doing is analyzing data, describing what a sample looks like, figuring out where's the middle, how spread out is it, and how does one thing compare with other pieces of data. We're going to be looking at all of those things today, and in the process, we're going to be learning how to use your calculators efficiently. You should have a graphing calculator for this class. And if you happen to be stranded at home and don't have one, get back to me and we'll talk about some ways that you can download one, like the ones I use for examples in class, so that you can make sure you get all the work done. But we will be using graphing calculators to do most of our math. And what we want to do is find various calculations of one variable statistics. Now, I actually talked about part of this last time when we were going through how you can sort data, but we're going to talk first of all about entering data. And to do that, you first of all want to hit Stat on your calculator. Stat's right next to the arrow keys, and it gets you into statistics mode. Once you're in stat mode, you want to choose edit and you want to go to L1. Now, I'm going to have a handout that explains everything, and it also talks about what to do when things go wrong, like if you look at your list and L1 isn't there. And then what you want to do is the choice that says set up editor to get things back to normal. But what you're going to do is type all your numbers in list number 1. And you can see, for example, that I have on list 1 here typed 1, 2, 3, 4, 4, 5. So like the numbers from 1 to 5, but I repeated 4. Type all of those in there, and I just type the number, hit enter after each number, and I have all of those in my list. Once I have everything in the list, I can just hit quit, which again is second, and then the key right next to second. And that gets me right back to the main screen so I don't screw anything up. And once I have numbers in my list, I'm ready to do one variable statistics. I'm ready to find things like averages and spread and all of the other things that we can find using one variable stats. So the first thing we're going to talk about is what are officially called measures of central tendency. And all that is the world's fanciest way of saying averages. We're trying to figure out where the middle of something is when we find a measure of central tendency. Now, you guys know from about 4th grade that there's more than one kind of average. As a matter of fact, there's probably close to a dozen types of averages I could have you guys do if I wanted. We're not going to look at that many, but we are going to do the ones you already know how to do, what I call the big 3. And we're going to talk about a couple other ones, one because it's really easy, and one because it's really important. So we will be learning a few things that you don't already know as well. There are a bunch of different kinds of averages, and exactly which one you use really depends on the situation and what you want to know. So we're going to start by reviewing the big 3, the ones you do already know, and we're going to talk about how you would do that by hand, but more importantly, how you would do that with a calculator. So we'll start with the mean. Mean is what most people mean when they say the word average. If I gave you a bunch of numbers and said, find the average of these, what you would almost certainly do is add them up and divide by how many there are. What you're finding, if you do that, is the mean. And that kind of average has a lot of uses, but there sometimes are some reasons why it could be a problem. There's 2 different symbols that we often will use when we're talking about the mean. The first one is the Greek letter mu. Mu looks like a U that has a tail in front of it. It's actually where we got our letter M from. And you might have seen that in things like the metric abbreviation for micro. Mu is what's used for that. The other abbreviation is X bar. X with literally a little bar on top of it. You're going to find as we go along in statistics that whenever you see Greek letters, those stand for parameters. They stand for information about the whole population. Like if I wanted to know the average height of every student at Garrigan, I'd be looking for mu. X bar, you're looking at the mean of a sample. Like if I looked at 25 students and I figured out what their average height was, that would be X bar. Typically, English letters stand for samples. Greek letters, like the mu there, those stand for parameters for the whole population. You guys do know that if you want to find the mean, you add everything up and you divide by how many things there are. You've done that going all the way back to grade school. On the next screen, I have the same thing written a different way. And while you don't need to know this formula, it is there for a reason. It's there to show you a symbol that's going to come back to haunt us as we go forward. And it's this weird thing that looks kind of like a pointy E. It's the Greek letter sigma. And what it means is sum or add up. This is saying I can find the mean by adding up all the x's and then dividing by n, by the number of things there are. So that's exactly what you do if you want to find the mean. So if I had this particular example where I'm trying to figure out the mean of 1, 2, 2, 3, 4, 5. Now notice that's actually a little bit different than the numbers I put in the calculator earlier. The 2 is what repeats instead of the 4. What I'm going to do is add all of those up and then divide by 6 because there's 6 numbers, and the mean is going to end up being 2.83 repeating. The mean very often will be a decimal, and it doesn't necessarily have to be one of the numbers you started with. It usually won't be one of the numbers you started with. It does need to be somewhere in the middle of your numbers, but that's about it. It is pretty straightforward to figure out the mean if you have numbers in a calculator. And since this is using the same numbers that I had in there before, we're actually going to get a little bit different answer than what I just got with the sample I showed you. But once I have my numbers in there, what I do is I go back to stat. And this time I want to choose calc, which just stands for calculate. The default choice is one variable stats. So basically all you're going to do is hit enter twice. You hit enter once, it puts it on the screen. You hit enter again, and it gives you your answers. And you're going to get a readout that looks really complicated, but really there's just one thing we care about for now, which is the very first number on here, 3.16 repeating. Now, again, that's a different answer than I got with what I computed by hand. That's because the numbers in the calculator, it was the 4 that repeated, but the ones I did by hand, it was the 2 that repeated. And so you do end up with a little bit different answer when you do it that way. So again, you put all the numbers in your calculator, go to stat, calc, one variable stats, and what you're looking for is X bar up at the top. That's your mean. And, so again, not all that difficult to do. So the mean is pretty straightforward to calculate things on. It's not a real complicated thing to do. But it can have a problem because it can be very badly affected by outliers. And to explain to you for a second how that might work, that you might have something that's badly affected by outliers, I want to think about, let's say that you ended up getting out of college and you got like an internship at some company where they were going to pay you $25,000 a year. And you start asking around to the other employees, and the person that works next to you, they make $25,000 a year. And you ask some other folks, and they make $25,000 a year. And it turns out that you asked 9 different employees, and all of those people make $25,000 a year. And then you ask the boss, how much money do they make? And the boss ends up making $1 million a year. Well, you'd probably agree the boss is an outlier here. They make a lot more money than everybody else. Well, if you took those numbers and you took all those people that made $25,000 and you throw the boss in there, if you find the mean of those numbers, it tells you that the average is going to be $122,500. And if you think about it for a second, that doesn't really represent anybody at that company very well. Most people at that company made way less than 122,500. The boss made way more. And so the mean isn't really doing a very good job of representing what most people at this company make. An outlier, like that rich boss, is going to affect this income. The same thing would happen if I was maybe looking at the average income of all Americans and I included a homeless person. Something that's way less than everybody else might also affect the overall answer. So it's going to give you some differences if you have an outlier. One of the ways we can avoid that is to instead talk about the median. And again, I know you guys did that back in junior high. The median just means the exact center of your group. It's, if I lined everything up in a row from smallest to largest, you'd have the same number on one side as you do on the other. That's what happens with the median. There's a couple of symbols that sometimes are used for median. By far the most common is MED, and that is what you'll see when you look at a graphing calculator. I'll show you how to find that in just a minute. I put another one on here just because you might end up seeing this like in a college class. It looks like it belongs in Spanish class. It's X with a little tilde symbol on top of it. It's just another symbol that means median. Anything I'm going to ask you to do, though, it's going to say MED if you're supposed to find median. You should know that if you want to find the median by hand, you sort out the data from smallest to largest. That's actually one of the reasons we talked about stem and leaf plots, was as a way of sorting data. If you happen to have an odd number of things, you literally find the middle item, and then you'll have the same number on both sides. And if there's an even number of things, what you do is you average the 2 middle numbers. You just add them up and divide by 2. So like here's 2 examples. If I had 1, 2, 2, 3, 4, 5, there's 6 things there. So I just average 2 and 3. Halfway between 2 and 3 is 2.5, and 2.5 would end up being the median. On the other hand, if I had 2, 4, 6, 8, 10, the middle number is 6, and so that's my median. Again, if it's an odd number, it's just literally what's in the middle. If it's an even number of things, you average the 2 that are in the middle. The median very often will be one of the numbers that you started with, but it doesn't have to be. It often is, but you don't have to have that number in your data. Now, it's really pretty easy to find the median on your graphing calculator as well. When you do one variable statistics, you might have noticed when we went through things before that there was a little arrow down at the bottom of the screen. And what that means is there's more stuff that you can see, which you can find by just hitting the down arrow on your calculator repeatedly. And if you hit the down arrow a couple of times, you'll see a screen that says like min x q1 med. Med, MED, is the median that we're talking about here, and this time it's going to be 3.5. Now again, this will be the numbers that were stored in the calculator as opposed to what I did by hand earlier, so it isn't the same as what I did earlier, but 3.5 would be the median of 1, 2, 3, 4, 4, 5. Especially if you have outliers, the median is typically going to be a more accurate kind of average to work with than the mean. They both get used a lot, but median often gets used in a lot of government and business statistics precisely because it doesn't get as affected by outliers. So mean and median, and you probably remember the third of the big three is what was called the mode. Mode just means the most common number there is, and there is no standard symbol that stands for mode. What's more, your calculator will not directly compute the mode for you. I'm not quite sure why that is, because honestly, I could write a program that would do that, but the people at TI didn't. So unfortunately, mode you have to recognize by hand. What you do for mode is you just look through your data and you figure out what repeats, and in particular, what repeats the most. And if you happen to have a tie, then you give 2 or 3 different answers for the mode. That's literally what bimodal that we talked about before stands for. It means 2 modes. You could also have like trimodal data that would have 3 modes. So like if I had 1, 2, 2, 3, 4, 5, the only thing that repeats is 2, so 2 is the mode. On the other hand, if I had 2, 4, 4, 4, 6, 6, 6, 8, 10, 10, 2 things repeat more than anything else. 4 repeats 3 times and 6 repeats 3 times. So here I would say that 4 and 6, both of those are the mode. Not 10 because it doesn't repeat as many times, but 4 and 6 are going to be the modes. And if I had something like this one, 5, 5, 10, 10, 15, 15, etc., this time we're going to say there is no mode. You know, this is not like junior high track where everybody gets a medal. We've got to actually have some sort of winner, and so no, it's not going to have a mode for this data. If you do have a mode, if it does actually exist, it's always going to be one of the numbers you started with because that's the whole point of the mode, is it's the most common, so it had to be there to begin with. Your graphing calculator won't directly find the mode, but remember that last time I told you how you could sort data, and if you do that, it can make it easier to locate what the mode is. And just to remember again, once you've got your numbers in there, you want to go to Stat, Sort A, and then second one to put L1 on the screen, and it'll go through and put your numbers in order for you. So I want to talk about a couple of other kinds of averages real quick as well. One of them is incredibly easy and the other one's not hard. The fourth of the kinds of averages we're going to talk about is the mid-range. In mid-range, it says it's the halfway point. Now sometimes people will see that and they'll say, isn't that what you told us that the median was? Well, it's not quite the same thing. What you're doing for mid-range is you're literally averaging the bottom number and the top number. So the formula for it says you take the maximum plus the minimum and you divide by 2. So whatever your numbers are, you just look at the smallest one, the biggest one, you add them up and you divide by 2. You're averaging top and bottom. And you might have noticed when I was showing you where median was before, that you can find max and min there as well. So like on the set of data I had in there, I would take 1 plus 5 and divide by 2. Not too hard to figure out that 6 divided by 2 is 3. So you'd end up with 3 on here. Again, mid-range, you just take the top and the bottom, add them up, divide by 2, that's the mid-range. The last of the averages that we're going to talk about is what's called a trimmed mean. The trimmed mean is another way that we often will deal with outliers. It's really probably the most common way of dealing with outliers. What you do with a trimmed mean is you get rid of some data from both ends of the spectrum. It's like I trim off the bottom, but to balance that out, I trim off the top as well. And then I find the mean of what's left. That's what you do with a trimmed mean. Now I want to show you an example to show you how that works. Here's a bunch of numbers, and you can see that most of them are relatively small, 3, 4, 5, 7, 8, etc. But we also have a 500 in there that I think most of you would agree is way bigger than every other number in this data. That 500 is very definitely an outlier. It's way too big. Well, it turns out that if I just found the mean using my calculator, one variable statistics, it's going to tell me that it's like 35.85. And if I go back to that data, it's not too hard to see that 35.85 is way bigger than all but one of the numbers, and it's way smaller than the other one. And it's exactly like that millionaire boss at the company. It's making the average way bigger than what it actually should be. And so this is an example where a trimmed mean would be a very logical thing to do. Now, when you look at directions, it'll typically say some percentage of trimmed mean. What I'm going to do for this example is we're going to find a 10% trimmed mean. What that means is I'm going to get rid of the bottom 10% of my data, and I'm going to get rid of the top 10%, and then we're going to look at what's left in the middle and find the average of those. So what I have to first of all do is realize, and I'm going to go back for a second to those numbers, we had 20 numbers to begin with. And so what I'm going to do is figure out that 10% of 20 is 2. What we're going to do is get rid of the bottom 2, the 3 and the 4 at the bottom, and the top 2, the 20 and 500 at the top. That's the page I wanted. And we'll average out the others. So I figure out what 10% of that 20 is, and I get rid of that many scores from the bottom and the same number of scores from the top. To keep things fair, you've got to trim off both ends, because if all I did was trim off like the part that had the outlier, now I might actually get too small of an average because the other end's affecting it. So you trim off the same number from both ends. The easiest way to do that is literally go back into your list in your calculator, delete the bottom 2, delete the top 2, and you're good to go. So like here's a screenshot after I did that. We started off with 20, and I deleted the first 2 at the top, I deleted the last 2 at the bottom. You can see in the screenshot that it says that we're in L1 number 17, where the blank is. That means there's 16 items left. So I got rid of 4 of them. And what's left is going to end up being the number 19, which used to be the third one from the end. So I get rid of the bottom 2, I get rid of the top 2, and now what I'm going to do is go back and just hit like calculate one variable stats again, and I get a completely different answer. I get 11.875. Well, 11.875 is much closer to where most of those numbers were for an average than the answer I had before, the 35 something. So again, all I do is get rid of a percentage from the bottom, the same percentage from the top, re-average everything. That gives me my trimmed mean. And when you do a trimmed mean, you always end up getting rid of that same number on both sides. You get rid of the outlier, but you also balance it out by getting rid of something from the other end. And so again, for your measures of central tendency, your averages, you've got the mean, where you just basically add them all up and divide by how many there are. X bar was the symbol on your calculator. The median, that's the exact center. The mode, that's the most common. We talked about the mid-range, where you average the top and the bottom. And then we talked about a trimmed mean, where you get rid of numbers from both ends and average what's left. And that's basically the first part of one variable statistics, is finding those averages, finding measures of central tendency.